Section 2.5, Graphing Linear Inequalities, example number 2. We're going to graph y is greater than 1/3 x plus 2. Of course, the first thing we need to do is graph the boundary line, which is pretend like this is an equal sign. So y equals 1/3 x plus 2. You can certainly use slope-intercept form there. I prefer to get a couple of ordered pairs and do it that way. Since I have a fraction in front of x, I want to pick multiples of x. So 0 and 3, 6, 9, 12, any of those would work. When I put 0 in for x, that gives me 1/3 times 0 plus 2, which is 2. If I put a 3 in, that's 1/3 times 3 is 1, plus 2 gives me 3. So now I have two ordered pairs to graph. So I have 0, 2 is right here. And then I have 3, 3 right here. Now the previous example we drew a solid line for the boundary line because there was an inclusive inequality. Here we have a strict inequality, so we have to use a dashed or dotted line to represent our boundary line. So here's our line. And we have to figure out which side to shade. I like to pick a test point on either side just for good measure. Some people say that's overkill, but that's the way I do things. So I'm going to test 0, 0 is the easiest point to test if it's not on the line. I always pick the origin. And I need something up here. 0, 2 is on the line, so I know that 0, 3 is not. So those are the 2 points that I'm going to test. Of course, we have to go back to the original inequality when we do our test. So when I test 0, 3, I have y is greater than 1/3 x plus 2. When I substitute that in, I'm going to get 3 is greater than 1/3 times 0 plus 2. That gives me 3 is greater than 2. That is true. So I'm going to shade this side. But sometimes you have a day where you don't do your arithmetic perfectly, so I like to double check myself. So I'm also going to test something on the other side, 0, 0. Y is greater than 1/3 x plus 2. That's going to give me 0 is greater than 1/3 times 0 plus 2. 0 is greater than 2. That is false. So don't shade this side. I'm going to shade up here, and there we go.